All right, in this video, we're going to look at the transformation problems when we're describing how the graph is moving without actually looking at the graph. Okay, so recall from down below, we have the generic form of the equation, the f of x equals a times x minus h squared, and then plus k. And recall from the notes that we took last week that a can affect the graph in two different ways. It can correct the graph by the value of a, which is going to cause a stretch, or the sign of a, which can cause a reflection. And then h can affect the graph by causing it to move left and right. And k can affect the graph by causing it to move up and down. Okay, so when we're looking at the problem on the left, the best strategy for that is to ask ourselves, what is different about the second equation compared to the first? Okay, so looking at this equation, the first thing that I notice is that I have something in front of x in the second equation that's not there in the first. And comparing that to my f of x equation at the bottom, that's an a value. Okay, so for a, I have a -2. Okay, I have a sign change and I have a value change. Okay, so when I'm describing the transformations in words, I'm going to write down what those changes are. So looking first at my sign change, okay, at my sign change, that's going to cause an x-axis reflection. Okay, so I have an x-axis reflection. Okay, so that's from having a negative a value. You don't have to write this when you do this problem, but just to help you associate where I'm getting this, that's from having a negative a value. Okay. The second one is that my a value is not 1. My a value in this problem is a 2. And because that number is bigger than 1, I'm also going to have a vertical stretch. Vertical stretch by 2. Okay. And that's coming from the value of a. From the value of a being greater than 1. Note that if it's less than 1, if a is less than 1, then you would say vertical shrink. Okay. Okay, so that's covering what I'm seeing in front of the x value here. Okay, in addition to that, I'm also noticing that I have a house here, I have parentheses, and I have a number that's next to x that's also being squared that I don't have up top. Okay, and comparing that to the equation at the bottom, I can see that that is an h value. Okay, and since h moves us left and right, I know I'm going to have a shift either left or right. But remember, h is a rebel child, which means that even though I see -3 in the equation, I'm not moving towards the minus numbers, the negative numbers, which are to the left. Instead, I'm moving to the right. Moving to the right 3 units. Okay? I'm not moving towards the negatives because it's a rebel child. Okay? So that's covering my second number that I'm seeing in my equation. And the third number that I'm seeing in the equation that is different from the first one is this -1 on the end. And since -2 associated to A and -3 associated to H, I know that -1 has to associate to K. And I can also tell that because it's being added after the equation, or after the exponent, so therefore it has to be K. And K, by definition, is going to cause us to move up and down, so therefore I know that this one is going to cause me to do that. And because K is a cool kid and he always does what's expected, we know that since it's negative, the negative numbers live low, so we're going to move down 1 unit this time because the number is 1. Okay, so in each one of these problems, you can see up to 4 transformations from these numbers. Sometimes you may not have a K value, which means you don't have that movement. Sometimes you might have a missing house, which means no H value. So you don't have the H movement. And then when you look at A, you have to look at, does it have a value? Does it have a sign? It could have one of each, it could have neither, it could have both. Okay, so when you're doing these problems, you're not actually doing any calculating, you're not doing any graphing. All you're doing is you're writing down the transformations. Okay, we did vertex notes last week. If you don't have them, look in Google Classroom because the completed notes are there for you. And it defines how each of these move the graphs, and it will help you to figure out what's different from the equation and how it's changing the graph. Okay? On the other side of the screen, you'll see that this problem is actually in reverse. I'm giving you those statements, and you have to connect those to where they belong in the equation and work backwards to reconstruct the equation for them. Okay? Notice there's 4 statements, which means we're going to have 4 transformations. Okay? So I'm going to start with the g of x notation. Okay, f of x was the original equation, g of x is the changed equation. And the first transformation that I note is that I'm going to reflect across the x-axis. Okay, and the reflection is going to come from the sign of the a value. Okay, so after the equal sign, I know that if my sign of a has to be different, that I have to introduce a negative number, because originally it's positive. Okay? And then I also notice that I'm expanding vertically by a factor of 3. And the word expand is a synonym to stretch. Okay? So that tells me that the value of A is also going to be changed. When we don't write the number in front of a variable, it's a 1. And I need to change that so I'm stretching by a factor of 3. Which means instead of having a 1 in front of my parentheses where my x is, I need to have a 3. Okay? The next transformation is the translate right. Okay? That's synonymous with shifting or moving. Shift or move. Okay? And so the question is, which letter in the equation moves us left and right? Okay, we've already said that A causes us to stretch and reflect, but H is the one that's going to cause us to move left and right. And if I'm introducing an H into my equation, I have to build a house. I can only have H if I have a house. So after my -3, I'm going to do parentheses. And then after the parentheses, there's always an X. And I'm moving right 1 unit. And if you think of the graph, moving right 1 unit is moving towards positive numbers. And since h is our rebel child, I'm going to put a negative sign in the behind the x in the house. And I'm moving 1 unit, so I'm going to do -1, close my parentheses, and put my square. I need my exponent of 2. That's part of what makes this equation quadratic. Okay? And that covers my third transformation. And then my fourth one is to move up 2 units. Okay? I've said that A caused the stretch and expansion, or the stretch and the reflection, excuse me. I said that H caused the left and right movement, so the last letter for up and down is going to be K. And again, since K is true, whatever sign you see is what you should be putting in the equation. So up is towards positive numbers, so I'm going to put up 2. Okay, so what I have here is 4 changes to the equation, that have caused the graph to move according to the 4 transformations that were described above. So this was the first one, the reflection. This one caused the expansion. The -1 caused the move right. And the +2 caused the move up. Okay? And that's it for that problem. So work on the problems that you have for practice. Try your best to get them right. Best of luck.